So the concept of albedo is just reflectivity, nothing more. And in atmospheric science, the word albedo crept in. I don't know how that happened. I don't know why we don't just call it reflectivity and go from there. But anyway, I'll use the terminology, and well, I guess you'll need to learn it. So every substance has its own reflectivity, and you don't need like to per se memorize these, but just to kind of think about what's going on. And at the end, we're going to look at water as kind of a special case. So typical albedos of some surfaces, clouds, big range there. Some high thin clouds might be 15%, even less. I mean, depends how thin they are. Real thick tropical convective clouds with thunderstorms and deep moisture, 90%. So in other words, only 10% of the sun would get to the surface. Wow. So if you go to some of those zones and around the equator where we saw before there wasn't much solar radiation, that's what's going on. Those big thick clouds. Concrete. Well, I don't know if that's surprising or not, but it rains there. How would that compare with blacktop or pavement? That's something to think about. So, which is like saying what's going to absorb more, a dark colored shirt or a light colored shirt when you're outside on a hot sunny day? So asphalt, yeah, the reflectivity is less, so it absorbs more. Everything else being equal, it should get hotter over time if you had a concrete and asphalt surface together. There are other factors, though. One of them might be how thick the slab is, how conductive it is, how good it, in other words, it is conducting the heat away, and so on. But by and large, you would expect asphalt maybe to be a little hotter because it's absorbing a greater share of all the radiation. Green crops, wide range there. Wet soil also varies some depending on the kind of soil it is. I suppose how wet, a little bit too. Very shiny, wet surface might be a little more reflective. Wow, fresh snow. Okay, so here's how you really get a sunburn. Go up into the mountains in the spring when the solar altitudes are getting higher, like right about April, late March. I remember doing this spring break and got really sunburned a couple times. 80 to 90% of the solar radiation reflects off, and that includes the ultraviolet radiation, which will really give you a sunburn. The other thing that'll really give you a sunburn in being high altitudes is there's less atmosphere for the sun to go through, so less to scatter it, filter it, reflect it back, and so on. So fresh snow is even worse, generally speaking, than being on water in terms of getting sunburn because of the altitude, because the reflectivity is so high. Now, special case of water. Wow. Water can be either not very reflective or highly reflective. So here's the thing. What causes that is the solar altitude. If the sun is very high in the sky, say 30 degrees or more above the horizon, most of that solar radiation, almost all of it, makes it in. But when the sun gets low in the sky, and you know this, if you've ever been like to a lake or the ocean late in the afternoon or in the early morning, might be around the lake if you're on the west shore looking towards the sunrise and here's the sun coming up over the water, you can see a lot of reflectivity, just kind of blinding glare. Well, that's the reflectivity of water. So albedo of water is not very high when the sun is high in the sky, but in very low, like early in the morning, late in the afternoon or evening, then yes, it becomes more reflective. And also if you're in the Arctic in general, because the solar altitudes there are never very high.